This is section 13.2. All right, so we're doing derivatives and integrals of vector functions. It really isn't that big a deal. Again, from last time, if you have a function, we're calling it a function, but when you open it up, there's three parts to it. There's an x part, a y part, and a z part. If you want to go straight by definition, and you don't really need even to copy this down, but dr dt, the vector r or r prime, looks like calc 1, limit h approaches 0, r of t plus h minus r of t all over h, okay, if the limit exists. Okay, so that really shouldn't be that big a deal. Here's something you might want to know. So r prime gives us a tangent vector. Unit tangent vector is r prime divided by magnitude of r prime. So we already know that. Okay, so r prime gives us a tangent vector. If you want a unit tangent vector, then of course we know divide by its magnitude. Okay, and here are some pictures here of r prime. So if you've got a space curve, let's say going along here, okay, then r prime can be thought of as a direction at that moment in time that the particle is moving, right? So if you're on a roller coaster, right here, you're aiming that way. And then right here, you're aiming this way and so on. So it'll change as time goes by. And you can see we can come up with a secant vector and a tangent vector. Defined similarly to Calc 1, we won't really look at that too much. How do you find a derivative? Simply differentiate each component. So again, we say the vector function r of t, but when you open it up, there's three parts. There's an x part, a y part, and a z part. So differentiate the whole thing, you just differentiate each one, f prime of t, g prime of t, h prime of t, right? And same thing works for integrals also when we get to it. All right, and let's see. Here are differentiation rules, page 858. You don't really have to worry about any of them, I don't think. They're either very obvious or we don't need them that much. Derivative of a sum is the sum of the derivatives. Derivative of a constant times a function is a constant times the derivative of the function. It looks pretty much like Calc 1. Okay, this sort of looks like a product rule. However, it's a vector function multiplied by a scalar function. Okay, and this looks like a property of dot products, property of cross products, and a chain rule. Okay, don't even bother memorizing these or putting these on your formula sheet. I don't think that they're necessary. And integration. Okay, integral of r of t, just integrate each part. The x part, which gives you an I component, the y part, which gives you a j component, and the z part, which gives you a k component. So we're going to say we're integrating the integral, but in the process of integrating the integral, you integrate three integrals at one time. So again, we call it one function, but you open it up and there's three parts. Okay, and you can see the fundamental theorem of calculus still holds. R of b minus r of a there at the bottom, which really means plug in the top number, plug in the bottom number, and subtract, just like before. It's not just one function, though. There may be three functions involved, the x part, the y part, and the z part, of course. Okay. All right, so that's pretty much about it. Page 860. Again, for the benefit of those who don't have the book and aren't getting it, show you the problems. Kind of going through it somewhat quickly, but you can always might have to adjust this. Yeah, you can always fast forward or pause and rewind as much as you need. So that. Okay, 17 and 19, find a unit tangent vector. So first find a tangent vector and then make it into a unit vector. We know how to make it into a unit vector. And then we have some integrals there. You're just basically integrating each part. And I think we had to go as high as 41. Okay. Okay, number 3. So r of t is t minus 2. Looks like I messed up there. T squared plus 1. This is the x component, y component, two-dimensional. All right, so I just made a little table from -3 to 1, plug in -3, -5, -2 gives me -4, and so on. 1 gives me -1. Then I plug in here. So -3 gives me 10, -2 gives me 5, -1 gives me 2, 0 gives me 1, 1 gives me 2. All right, so I connect them and it seems to be somewhat parabolic. Okay, and they want to talk about something at t equals -1, right? So first I find r prime. What is r prime? Just the derivative of this function, which has two parts. Just give me the derivative t minus 2, which is 1, and the derivative of t squared plus 1 is simply 2t. And then I plug in -1. Okay, so plug in -1, you get 1 comma -2. So that's r prime. All right, so we graph r. So r is a position vector, so it always starts at the origin and it goes out to here. R prime is the vector 1, -2, which from here is 1 right and 2 down. So on this parabola, right at that instant in time, okay, this is the tangent vector going right there. Okay. All right. So they wanted the position vector at t equals -1. There it is. And they want the tangent vector. There it is. Number 7, here's r of t, 4 sine t, -2 cosine t. That's x, that's y. And they're talking about at time t is 3 pi over 4. So I decided to make a table from 0 to pi. So plug in 0, sine of 0 is 0. Plug in pi over 2, sine of pi over 2 is 1. 1 times 4 is 4. Plug in pi, sine of pi is 0. Either pi over 4 or 3 pi over 4, the sine comes out to be radical 2 over 2 multiplied by 4. You get 2 radical 2, which is about 2.8. Then -2 cosine of t, plug in 0, cosine of 0 is 1, multiplied by -2, you get -2. Cosine of pi over 2 is 0. Cosine of pi is -1. -2 times -1 is a positive 2. Cosine of pi over 4 is radical 2 over 2, multiplied by -2. Negative radical 2, which is about -1.4. And plug in 3 pi over 4. Cosine of 3 pi over 4 is negative radical 2 over 2. Multiplied by that, you get radical 2, which is about 1.4. Okay. And then I plot all the points and I get something like this. It looks like it's elliptical. Okay. So first I computed r of 3 pi over 4, which is this. So the position vector is right over there. Okay. Then for r prime, you take the derivative. Okay. I trust you can take the derivative. That shouldn't be any big deal. Okay. And then you plug in and you'll see that the tangent vector goes something like that. So I leave that to you to figure out. That's pretty easy derivative, right? 4 cosine t and 2 sine t, and you plug in. Okay, so at that instant in time, that's the position vector. That would be the, so the point is 2 radical 2 radical 2. Okay, but this would be the tangent vector. Okay, number 9, here's a position vector, which I'm going to write as t minus 2 to the half, 3 t to -2. They ask for r prime. So what is the derivative of the function, meaning differentiate 3 times? Take this derivative, take this derivative, take this derivative. So the derivative of t minus 2 to the 1/2 is 1/2 t minus 2 to the -1/2. Simplifies to that. Derivative of 3 is 0. This treat as t to -2. So the derivative is -2 t to -3rd. So here is the derivative, even though we did 3 derivatives, the x part, y part, and z part. Okay, 13, here's r of t. Find r prime. It means find 3 derivatives. It's like part A, part B, part C, or part X, part Y, part Z. So product rule, first times derivative of the second, t cosine t, plus second function sine of t times derivative of the first, which is 1. And this one, first times derivative of the second, is negative e to the t sine t, plus the second times derivative of the first, it'll just be the same thing, e to the t cosine t. And product rule here, first times derivative of the second, sine t times negative sine t, negative sine squared t, plus the second cosine of t times the root of the first, which is also cosine t. So negative sine squared t plus cosine squared t. Okay, 17. Here is r of t. We're asked for the tangent vector and unit tangent vector also. Okay, so at t equals 2, so tangent, take the derivative, 2t minus 2, 3t squared plus t. Now I plug in 2. So plug in 2, 2, 3, 4 plus 2 is 6. So that's the tangent vector. To make it into a unit tangent vector, I just divide by its norm, its magnitude. So 2, 3, 6 divided by square root of 2 squared plus 3 squared plus 6 squared. That's 4 plus 9 is 13 plus 36 is 49, whose square root is 7. So the unit tangent vector, capital T, is 2 sevenths, 3 sevenths, 6 sevenths. Okay, 21, R of T is T squared, T cubed. Okay, they ask for R prime, which is 1, 2t, 3t squared. Double prime is 0, 2, 6t. Then they said to plug in 1. So plug in 1, 1, 2, 3. Then they say make it a unit tangent vector. 1, 2, 3 divided by its magnitude. Square root of 1 squared plus 2 squared plus 3 squared. 1, 2, 3 over radical 14. Okay, and unless otherwise we need to, you can just write it like that. You don't have to write 1 over radical 14, 2 over radical 14, 3 over radical. You can just leave it like so. Okay, then for some reason they ask for R prime cross R prime. We'll see why later. But it's I, J, K. R prime was 1, 2t, 3t squared, and R double prime was 0, 2, 6t. So the I component is that minus that, 12t squared minus 6t squared. The J component is the opposite of 6t minus nothing, and the K component is 2 minus nothing. Okay, so that gives me 6t squared, negative 6t, and 2. Problem 25, you're given x, y, and z. They could have written it in vector form also. Brackets, e to negative t cosine t, comma, e to negative t sine t, comma, e to negative t, and so on. Okay, the point to give us is 1, 0, negative 1. First, I need to find out the corresponding t. It's probably easiest to look at this one. So what value of t gives me a z of 1? In other words, e to negative t is 1. That means t is 0. Okay, so time is at 0. And if you plug in 0 here and here, you also get 1 for x and 0 for y. All right, so R prime, product rule, first times derivative of the second, negative e to negative t sine t, plus the second times derivative of the first, minus e to negative t cosine t. And derivative of the y component, same thing, product rule, first times derivative of the second, e to negative t cosine t, plus the second sine of t times derivative of the first, negative e to negative t. And then the z component, derivative of e to negative t is negative e to negative t. Okay, then I plug in 0. So sine of 0 is 0, cosine of 0 is 1, put a 0 there. So that gives me negative 1. And then plug in 0 here and here. 0 there gives me a 0. That gives me 1 times 1, which is 1. And plug in 0 here, you get negative 1. Okay, so that would actually be the thought of as a velocity vector also, the derivative of a distance function. Okay, so tangent line, R is 1, 0, 1 plus a scalar multiple of negative 1, 1, negative 1. Okay, so that's just going to be 1 minus t, 0 plus t, 1 minus t. So that's that. Okay, 33. R1 of t is t squared, t cubed. R2 of t is sine 2t, t at t equals 0. So I take R1 prime, the derivative of this is 1, 2t, 3t squared. Plug in 0, you get 1, 0, 0, which is also I. And then let's see, what's the derivative of this vector? Cosine t, 2 cosine 2t, and 1. Plug in 0, 1, 2, 1. Okay, find the angle between the two curves, which means find the angle between the two R prime vectors, okay, the tangent vectors. So cosine theta is u dot v over norm u norm v. So that's 100.121 over magnitude of 100, which is 1. Magnitude of 1 plus 4 plus 1 square root is 1 over radical 6. So theta is inverse cosine of 1 over radical 6, which is 66 degrees. Okay, then we just have some integration problems, not really that big a deal. Integral from 0 to 2 of ti minus t cubed j plus 3t to the 5th k dt. It's almost just like doing 3 separate problems. You figure out that integral from 0 to 2, figure out that integral from 0 to 2, figure out that integral from 0 to 2. So no big deal. 1/2 t squared, negative t to the 4th over 4, 3t to the 6th over 6 is t to the 6 over 2. Okay, from 0 to 2. In each case, when you plug in 0, you get 0. So basically just plug in 2. That gives me 2. That gives me negative 16 over 4, which is negative 4. And 2 to the 6 is 64 divided by 2, 32. And remember, your answer is a vector. Okay, there's an x, y, and z part. 37, there's a little bit of substitution here. So that's going to be an ln thing, right? ln absolute t plus 1. That's your inverse tangent. This one, do a u substitution. Okay, so u is t squared plus 1. du is 2t dt, which means I need to introduce a 2 inside and a 1/2 outside. So that gives me 1/2 integral of du over u, 1/2 ln absolute value of u plus c. Plug back in 1/2 ln absolute value of t squared plus 1. But since t squared plus 1 is always positive, change it back to parentheses plus c. All right, so my integral becomes ln absolute t plus 1, inverse tangent of t, 1/2 ln t squared plus 1. And let's see, when you plug in 0, that's 0. Inverse tangent of 0 is 0, and ln of 0 is 0. So I just plug in 1, ln 2. Inverse tangent of 1 is pi over 4. And let's see, plug in 1 here, you have 1/2 ln 2. Okay, then 41 says r prime is 2t, 3t squared radical t, which is t to the 1/2. So that means I integrate r of t is t squared plus c1, t cubed plus c2, 2/3 t to 3/2 plus c3. Okay, and now it says r of 1 is I plus j. Another way of thinking of I plus j is the vector 1, 1, 0. Okay, which means x is 1, y is 1, z is 0. So for the x component, if I plug in 1, I get 1. So plug in 1 here. 1 squared plus c1 is equal to 1. That means c1 is 0. Okay, for y, I plug in 1, and I also get 1. So 1 plus c2 equals 1. Okay, well, that means c2 is also 0. And then when I plug in 1 for z, I get 0. So put a 1 here. 2/3 times 1 is 2/3 plus c3 is equal to 0. That comes out to be 2/3. So c3 is negative 2/3. So we found the c1, c2, and c3. So my r of t is t squared, t cubed, 2/3 t to 3/2 minus 2/3. All right, so that is section 13.2.